This is a Beautiful Mars podcast for Friday, June 30th, 2017, from HIRISE, on board NASA's Mars Reconnaissance Orbiter. This week, just what can that bright deposit actually be? In a 3D image from the context camera, we can see the northern rim of a 30-kilometer diameter crater situated in the western part of the Tharsis volcanic province. The image shows that a lava flow coming from the north-northeast surrounded the crater rim and rose to such levels that it breached the crater rim at 4 locations to produce spectacular multi-level lava falls. These lava falls cascaded down the wall and terraces of the crater to produce a quasi-circular flow deposit. Our image covers the 3 falls in the north-central region of the crater wall. The lava flows and falls are distinct as they are rougher than the original features that are smooth and knobby. The rough textured lava flow to the north has breached the crater wall at a narrow point where it then cascades downwards, fanning out and draping the steeper slopes of the wall in the process. This image shows partially exposed bedrock within the Kowalski Impact Basin, which is on the outskirts of the extensive lava field of Daedalus Planum. On one side, we see bright bedrock with scattered dark blue spots. The dark blue spots are boulders shedding from the outcrops. The color range of the bedrock provides some information on its composition. The blue color is indicative of the presence of iron-rich minerals that are generally not oxidized, unlike most of the ruddy Martian surface. Volcanic rocks are common on Mars. Possible candidate minerals for the bluish materials are often consistent with iron-rich minerals, such as pyroxene and olivine. The ridges may represent remnants of the original surface of the lava flows that filled the Kowalski Impact Basin. In this image, we see an impact crater with associated bright deposits that at first glance give the appearance of seasonal frost or ice accumulations. The Mars Reconnaissance Orbiter has an onboard spectrometer called CRISM that can distinguish between ices and other minerals. However, it can be deduced through several lines of evidence that this is in fact not ice. First, it should be noted that at the time this image was taken, the southern hemisphere is at the end of the summer season, so any frost or ice deposits have long since sublimated away. Second, numerous high-rise images of seasonal targets show that ice accumulates on pole-facing slopes. The deposits in question are situated on a slope that faces the equator and would not accumulate deposits of frost. Thus, it can be concluded that these exposures are light-toned mineral deposits. Gorgonum Basin is one of several large basins within the Terra Serenum region of Mars. Each basin has light-toned mounds, many of which contain clays. Scientists think that Terra Serenum once had a large lake during an epoch called the Late Noachian Early Hesperian, and each basin filled with sediments. The water within the lake may have altered these sediments to form the clays we now observe from orbit. Why the basin floors exhibit mounds similar to chaos regions on Mars is unknown, but could be the result of collapse and subsequent erosion within the basins. You can see these images and more at uahirise.org.